You remember this? The Apollo mission? We were all in awe of the amazing accomplishments that humanity had made. This was a feat of technology, a marvel that took us to the moon. One small step for man, one giant leap for mankind. That technology was amazing, wasn't it? You know how powerful that technology was? The Apollo guidance computer is what took us to the moon. It had the same computing power as today's musical greeting card, 2.048 megahertz. And today, we're marveling at NASA's rover Curiosity. It has about 1/7 of the computing capability of an iPhone 6. It's got a 2-megapixel camera. We laugh at 2-megapixel cameras. This is what we're marveling at. Welcome to the era of exponential technologies. And I'm going to explain to you what exponential technologies are because most people don't understand the difference between linear and exponential. We are human beings. We think linearly. This is an example that we use at Singularity University. If I ask you to tell me how far 30 linear steps is, I think all of you can take a guess as to how far 30 steps is. It's roughly 30 meters. If I ask you to tell me how far 30 exponential steps is, very few people in this room will be able to answer that question. 30 exponential steps is 1 billion meters. Now, 1 billion meters sounds like a lot, but do you know what that really means? 30 exponential steps is 26 times around the planet. That's the difference between linear and exponential. And that is how technology is progressing. Let me simplify this a little bit more for you. This is what you get for $1,000 in your computers. This is a chart that Ray Kurzweil, who's the greatest futurist of our time, put together. Ray estimates that as of 2010, for $1,000 in your laptops, in your desktops, in your smartphones, you got the computing power of a mouse brain. Now, I'm sure all of you have heard of Moore's law. This is how computing is advancing every year or two. Processing power is doubling, the prices are dropping, getting faster and slicker. Well, guess what happens by 2023 to your $1,000 device? This device here has the same computing power that you do, the same computing power as a human being. In other words, the iPhone 11, this is a near certainty, will have the same computing power that you do. By 2050, if Moore's law holds up, and there are very strong debates going on about how long Moore's law will continue. If Moore's law continues, then by 2050, this device has the computing power of every human being combined, of billions of people. Now, I don't know about 2050, but I know that IBM and Intel have both said that Moore's law will hold up until 2023, 2024. They have demonstrated 7-nanometer circuits. So the scary thing is, in about 7 or 8 years from now, these little things in your pocket are going to be as computationally smart as you are. And the advantage that they have over you is that they're networked together. They communicate at gigabit speeds. We communicate in slow motion. And here's the really scary thing. It's not just computing. It is everything that computing touches that goes exponential. Artificial intelligence, robotics, networks, sensors, synthetic biology, genomics, digital medicine, 3D printing, you name it, everything that goes digital goes exponential. And this is what is happening today. We are on an exponential curve. An exponential curve looks like this. We are now at this inflection point where everything is going exponential.